Hi, in this video I'd like to give you a brief introduction to the data models that underlie the Data Conservancy software. But first, I need to remind you of the Data Conservancy architecture, at least at a very high level. With that background, I'll then spend a few minutes talking about the two major data models that underpin that architecture. Here is a very high-level schematic depicting the architecture of the Data Conservancy system. As you can see, it is a layered system where the layers are quite decoupled with HTTP APIs between them. This allows for a separation of concerns. The lowest layer is the Data Conservancy Service, or DCS for short, which is the component that deals with archive and preservation services. It is the archive, if you need to use that term. The archive also knows about the relationships between various entities in its model. It knows nothing about the business layer. The next layer up is the business layer. It knows about higher level objects such as projects, collections, and data items, and the functions that people might want to perform on those sorts of items. Functions like creating a new project, assigning people to be members of that project, creating collections within that project, and including a certain set of files as members of that collection. On top of that is what is called the Reference User Interface. Why? Although the Data Conservancy team has developed a limited user interface, the expectation is that most institutions and organizations using DCS will want to develop or use their own interfaces in conjunction with the DCS. However, the Data Conservancy recognizes that it is important to have an example of how to do that, and it is also true that the Johns Hopkins University Data Management Service needs a user interface, so the Reference UI was built to fulfill those purposes. Some of the key reasons for this type of partitioned architecture is because the Data Conservancy wants to be able to support data from a wide variety of disciplines and needs to be able to evolve over time. The goal is that any of these layers, or actually any component within any of these layers, should be able to be swapped out and replaced by a different component or newer system at any time. In the Data Conservancy's first year of development, we actually demonstrated that with the archive itself, connecting it to Fedora, to a locally grown file system, as well as to an in-memory installation used for testing. Similarly, if a project needed a different business layer construction, they could choose to replace that. Yes, it would require resources, but it could be done. With that brief overview, let's talk about the data models underlying the lowest two levels in the architecture. The archive data model is what the DCS, the lowest layer in the architecture diagram, is based on. It reuses the core of the planet's data model. The fundamental unit of content is the deliverable unit. Deliverable units are what are archived and preserved for the future. A deliverable unit could be any digital object, an entire book, an entire data collection, a single data file, all the files that comprise what Esri euphemistically calls a shapefile, literally any digital object. A deliverable unit may have multiple manifestations or alternate versions. Say, for example, a data file in Excel format and its equivalent in comma-separated value format, or an entire book as a single PDF file, as well as a set of static TIFF images. Each of those manifestations then consists of one or more files or bit streams of data. As you might expect, manifestations are one way that the Data Conservancy can preserve data over time, creating a new manifestation of a deliverable unit if the format of the existing deliverable unit is becoming obsolete. In addition, deliverable units may have relationships with other deliverable units, the most typical being a versioning relationship where one deliverable unit is a new version of another, something that often happens with science data. As you might expect, all of the business objects, projects, collections, data items, files in the business layer map to one or more deliverable units in the archive. While the archive data model is rather abstract, the business object data model is made up of objects that are useful to people managing a Data Conservancy instance or trying to do research. Basically, the business model associates people with projects, projects with data collections with data items, and data items with files. Moreover, the model allows for a variety of relationships between these kinds of projects. For example, a common relationship would be that one file is metadata for a data item, or perhaps that file is metadata for an entire collection or project. The list of relationships directly supported at the moment is rather limited, but the system has been designed so that even if the system doesn't understand the relationship, it can store it so that that relationship can be used at a later date. As you might expect for a preservation system, a number of the currently defined relationships involve the ability to record provenance for objects once they are ingested into the system, as well as to be able to import provenance relationships to other objects either internal to the Data Conservancy or located in another system during that ingest process. The diagram only shows the current set of membership relations that are supported, but we expect that even this set of relationships will be broadened over time. So in summary, the Data Conservancy system employs two key data models: an underlying abstract data model used to preserve digital data within the archive itself, and a business object model that captures information about concepts such as people, projects, data collections, data items, and metadata, and translates these into archivable data objects. Moreover, while the business objects currently implemented within the DCS appear to be broadly applicable across a broad range of research disciplines, there is nothing that says that you, as an instance owner, couldn't define new objects, or for that matter, new relationships between objects if you decided that you needed to do so to support your community. Yes, that would take programming resources, but it is possible given the way the Data Conservancy has been designed. For more information on the Data Conservancy, please visit our website at www.dataconservancy.org.